Okay, last one is about me. Dr. Smith is late to class. Oh my. And he's running down the hallway from the main office in the direction of the cafeteria, which I'll call the negative x direction. So I'm going to go ahead and set up coordinates here. And oh, that's ugly. Let's see. Oh, that's even worse. Forward, and then let me get brushes. And now, let's set up, there we go. So there's our y-axis, and there's our x-axis. So initially, I'm running from the main office in the direction of the cafeteria, so I'm going this way. Okay, so going to the left. And I'm going at a speed of 4.0 meters per second. So I'm going to just draw in my initial velocity here. Is going to point that way. Pretend that's horizontal. Okay, and pretend it's a straight line. Okay, and I'll call that v naught. So v with a subscript 0 is 4.0 meters per second, and I'm going to call that due west. Even though these aren't correct compass directions really in the school, but whatever. Okay, and then I reach the intersection of the library and I turn to run up the physics hallway, and that sends me like that, and at a speed of 4. Okay, and then I go to speed of 3.0 meters per second as I finish. So when I finish, my speed is due north, or my velocity. So I'm going to call it v1 is 3.0 meters per second due north. Okay, so I've got my two states in this problem. I've got 0 and I've got 1. Okay, and the entire turn takes me 2.5 seconds. So what I'm going to say is my time here, t0 is 0, and t1 is, is 2.5 seconds. Okay. What is my average acceleration during this time? Okay, and this is really a piece of cake. All right, so to find average acceleration, we have acceleration. Average acceleration over some period of time is your change in velocity over your change in time. Okay, so my average acceleration from point 0 to point 1, or from state 0 to state 1, average is, and we need to know, we're going to need my final velocity, and we're going to subtract my initial velocity, and then we're also going to need my final time minus my initial time. Okay, now, to actually add or subtract factors, generally it's more helpful. Did I say factors? I meant vectors. Okay, whatever. It's generally more helpful to have them in unit vector notation. Unfortunately, these are two that are very easy to put in unit vector notation. So my final velocity, which is 3.0 meters per second due north, well, that's straight along my positive y-axis, right? So that's 3.0 j hat. And I could say meters per second if I wanted, but like I said, it's going to be v1. But like I said, who cares? Well, I don't particularly care about units for intermediate calculations. You can include them. Sometimes it's useful, sometimes it's not. Okay, so negative 4.0 I hat then was our initial velocity because we're going due west. Okay, so now I'm going to plug these in to my average acceleration equation here, and my v1 is 3.0 j hat, okay, right there, minus my negative 4.0 I hat. So negative 4.0 I hat, and that is all over 2.5, which was final time, minus initial time, which was 0. And let's see if I can just, I don't have more space on this page. Okay, so this is going to get kind of cramped, but let's okay, let's go up here. Yep. And so our average acceleration is going to be, and so it's 3.0 j hat plus 4 I hat over 2.5. And so there are two ways to do this. One is to, well, I mean, we can just leave it as a component form because we weren't asked for it in a particular format. So I'm going to put the I first just because that's more common. So 4 divided by 2.5 is 1.6 I hat, and then 3 divided by 2.5 is 1.2 j hat. And I am, let's see if I can move this at all. No. Okay, so let's see if, there we go, that gives me a little more space. Okay, so that is a 1.2 j hat, particularly poorly written there. Let's see if I can, let's see, 1.2 j hat, that's a little better. Okay, so that's my average acceleration in meters per second squared. You do have to have the units, so watch out for that. Now, if I wanted to actually convert this into polar, if I was asked for it in polar form, I wasn't in this problem. So technically, if this was the problem, you'd be just fine leaving it like this. And in fact, most cases, it's probably wiser not to futz around with an extra step of unit conversion, because that's just one other thing you could do wrong if you don't have to. If you are asked for an angle magnitude, or sorry, magnitude angle format, then you have to. What you would get is that, and I'm just going to write this in here because I don't have time to calculate it, but, or I don't have space to calculate it. It would be 2.0 meters per second squared at an angle of, and so let's look carefully here. My delta v, or sorry, my velocities are pointing this way and this way. And so what I'm actually doing, let's see, I'm accelerating in positive I hat, or the positive x direction, and the positive y direction. So it's going to be at an angle of whatever the arctangent of 1.2 over 1.6 is, of 0.75. So this guy does not have, let's see, view, scientific. Oh, wow, that isn't that fancy. Okay, so let's try 0.75, and let's just try inverse tangent, and so it looks like it's going to be at 36.9 degrees. So 36.9 degrees north of east. Okay, so that is my final acceleration, or my average acceleration is something like that. I like to put two arrows on acceleration to, you know, sort of differentiate it, just make it a different looking arrow, but nothing really special about that. So, and this, again, anytime you're making a turn, anytime an object is turning, you will be accelerating towards the center of the turn. Okay, that's just a rule. So anytime you're moving in a circular or semicircular path, if that's the path the object is taking, that is true, then it's accelerating toward the center. And we'll see more of that as we get into circular motion. Okay, so that's it.